Hello. Good morning, evening, afternoon. The usual. Hope everyone's having a pleasant Sunday. Welcome back to your regularly scheduled Sunday entertainment. Hope everyone's doing well. A few of the regulars rolling in. Good to see everyone. Quaco, Lucky on Twitch. Haran, Connor, Andre, Funky, Emery, etc. on YouTube. Hope everyone's having a good time. So, hopefully what we have up here is where we left it off on Friday, I think. Did we do a bonus stream on Friday? Can't remember now. It's been so long. Well, we've got textures working, which is exciting. So now we actually have a little bit more of an interactive scene. It's not perfect. There's no bitmaps. Kind of got this weird like fuzziness in the distance, which we will fix at some point. I'll try and not. We got this weird messed up UV at the back, which we don't talk about. So if I can not accidentally close the stream early this time. So yeah, today I want to, like, in my mind there was kind of three big features to actually getting to the point where we could think about assembling some sort of game, which is textures, lighting, and model loading. And obviously we did the texture loading last time. So today we're going to work on some lighting. It's not going to be super fancy. It's not going to be super complex. We're going to have an ambient light, a directional light, and a point light. And if we get time, we'll do multiple point lights, but I kind of want to at least get the mechanics in place of rendering those kind of lights. Diffuse and maybe specular. Again, we're only going to build what we need, so it's not going to have to be a full-blooded, it's not an engine, it doesn't have to have like every single possible feature, but I think we're just going to start today and just see where we get to. Fong, hopefully, be nice to have. What I quite like is, by the end of it, is to have an ambient light, a direction light, and then maybe one moving point light, so that kind of rotates around the scene, highlighting things. We'll see where we get to. But I think once we've got that, and then we'll do model loading, then I think we'll be in a good place. There's some other stuff I want to do, like HDR tone mapping, gamma correction, bloom maybe, but we'll see where we get to. So should have a relatively clean slate because we're just continuing from where we left last time. And yeah, let's have a look at where we are with main. So we create a texture and a sample object now. This was new from last time, and then at the moment we kind of we just poke those into the renderer in a pretty unceremonious fashion. Oh no, those go into the entity. That's right. So the entity now has the concept of a texture and a sampler that it has a non-owning reference to, well, a pointer to. Let's just check that. Yeah, so that has access to those, and then in the renderer itself, we bind those and send those. Like, again, we kind of, as we're going along, we're making some changes. I don't particularly like this, like these random zeros and stuff. What I suspect eventually we'll need to do is the entity will have to have a collection. So maybe a non-owning view over a series of textures and samplers, and then it can just loop through and bind them all, but here we are. This is what we're doing. Sorry, yeah, well, I thought this might happen, so someone was saying that, there's the unpredictability of the bonus streams kind of makes it hard for people to keep up. I do appreciate that. It's kind of it's a bit of a weird situation where, like, because I only want to commit code that we've written live on stream, if there's some stuff I really want to get through and I have the time, it's kind of worth it to me to do it. So I do apologise if that means not everyone can keep up with everything. It's kind of a bit of a balancing act. But at least, there is the 2 scheduled ones, and I've only done 2 bonus ones so far. We'll see. So we'll see how we get on. So I guess I can kind of only sort of partially apologise for that. Yeah, all the code is kind of available on YouTube as I type it. The repo is private at the moment, only because if it does end up that I can make a game of this, I wouldn't want to distribute that source code. What I will probably end up doing is releasing some subset of it maybe before like all the game stuff is in. Or maybe without assets. I don't know. I do want to release something, or maybe I'll make it. Maybe if you purchase the game, you get the source code as well. That's something I'm thinking about as well. So we'll see. But yeah, like I'm not hiding anything. The whole point, I'm doing everything live. So there's nothing hidden off stream. And all these videos go onto go onto YouTube anyway. Yeah, on YouTube. Yeah, I'm really enjoying this project. I think more than I really enjoyed the previous one, but the previous one was like the hacking toolkit was kind of a means to an end because it was something I wanted to do anyway. And two, it was really a chance for me just to kind of practice live streaming. It was the first time I've ever done it. It's the first time I've ever just sort of like gone live to people and start talking and try and, you know, be entertaining and engaging. So there was a lot of learning, a big learning curve on that. This is a little bit more open-ended, it's a little bit more graphical, you know what I mean? It's a little bit more interactive, and I'm just really enjoying it. I'm having a good time doing it. That being said, we need to start thinking about lights. So let's go to our scene object, because I think this is where I want at least to start with the lights to exist. Like the lights are part of the scene, at least conceptually. So let's include color, and then let's do color, ambient. So we'll have the scene will have an ambient color. This is just like, even if you had no lights on, this is about the baseline level of brightness and color that the scene will have. So if we just set this to 1, in theory, or 111, pure white, we'll have exactly the same scene we've got now. So we'll try to integrate this, and then we'll start fleshing out. Today you learned you aren't allowed to switch on pointers in C. You can switch on integral types, but switching on a pointer doesn't really make any, I guess, conceptually sense, because a pointer will just have one value, which would be a memory address, right? Like, what would you be hoping to get out of it, unless you're kind of abusing a pointer by stuffing extra bits in, which at that point you'd be better off, if you're in C, like casting it or memcopying it to an actual integral type. Yeah, I agree. The visual feedback of like, hey, and then like, because what I try to do as well is like when we get to a point when something's happening, it's nice to. I think it's kind of fun to take a poll or do whatever they call it on Twitch, a prediction. You know, it kind of gets everyone involved, and we can kind of have a laugh at my terrible code when it doesn't work. Cool. Thanks, Andre. Glad you're here. Glad you're enjoying the YouTube videos. But yeah, something a little bit different. This is, I guess, more forward engineering than the usual reverse engineering that I do. Okay, so let's start wiring this up. So we're gonna want. Let's get our shaders up. Now these are. That's something we did last stream as well. As we put these into. We built a separate. Resource loader, so we can have our shaders and stuff in and images in files and load them from disk. So I'm going to want to stick all the lighting stuff in a UBO, a uniform buffer object. That is just a block of memory that exists on the graphics card that we can write to and is made available to the shaders. So that's that's just how I'm going to start off doing it. We might change it in the future, but I think it's kind of a good way to start. So inside here we're going to have Vec3 ambient. So the color will then be the ambient light times the texture coordinates. I think I'm going to have a type mismatch there. Vec4. I think that's right. So we're going to give it our ambient light from the scene, and then we will push this into the shader, and then the shader will multiply. So the texture here is sampling the texture, and then what we'll do is we'll use that to modify the light. So we should be able to see that going pretty quickly. I've not messed with anything. So a question on Twitch about do I ever do anything with consoles? I've not yet, just because I'm not a big hardware person. It doesn't mean I wouldn't like to give it a go, but it's not my sort of usual kind of I guess like on my usual sort of project list. No, I didn't mean to modify it. Stood 1 for 1. Thank you. That is almost certainly a Vim. I probably hit Control A and I incremented it. Okay, right. So now let's think about this. So I think conceptually, the scene object will own the game representation of all the perimeters. So this will have like a position for the point lights and a direction for the direction light and the color, etc., etc. I don't think the scene should own the sort of the handle to the graphics memory that represents that. I want to keep scene as much as possible disconnected or decoupled from any of the actual rendering logic. So for that, I think in the renderer, I think in here where we have the camera buffer, we will also have a light buffer, and this will have our light data into it, and then we can go over to the render main. Let's leave that up for a second, and then this will have in the name. This will have a actual struct which represents that data, which mimics the layout of the shader struct, because there's a few weird oddities you have to do to kind of make sure they all align properly. And then what we'll do is we'll copy at the beginning of the frame, we'll copy all the light data into our sort of internal renderer specific struct, and then we'll then copy that over to the graphics card. Yeah, this comes up all the time, but it's my code and it's my choice, so I've chosen to use the British spelling for things. Okay, so let's do struct light buffer, and then here we'll need align as 16 color ambient, and I'll just bring in the color. And then sorry, that would be game color. So basically, when you create a uniform in OpenGL, as far as I'm aware, the vendor is kind of free to set the padding and the alignment requirements for all the members, and OpenGL provides you an interface for querying those. So I can basically say, hey, what's the alignment for this, and then what's the alignment for the next one. But if you had any more than one element to this uniform, it's quite tedious having to effectively runtime figure out what all those alignments are, and then you'd have to manually pack the structure yourself at runtime. What you can do is you can say use std 140, which is like a well-defined and well-known layout. It's a bit weird. Vec3s get padded. Basically, a lot of things get padded as 16 to alignment of 16. So your Vec3, although it's only 3 floats, will actually take up the space of 4 floats. So this is just what this does here. So this, in theory, now looks the same in CPU memory as this does in GPU memory. So that's just kind of what this little thing does here. So the question is, like, do you need the align as in GLM? I assume GLM. Well, so GLM, which is just the pre-built maths library, which you should absolutely be using rather than what we're using. Again, I don't know. This here is irrelevant to the maths library, right? This is a custom uniform buffer that you are defining, and you're basically saying what the alignment is. I doubt GLM will pad its vector. It's like vector 3s to 4 bytes to 4 elements, because it seems like a waste of space unless you need it. But I wouldn't know. I suspect you would have to do the alignment yourself. Yeah. Anyway, everyone uses std 140. It's terrible, but it's all we've got. And then there's std 430 for SSBOs, which is slightly more sane, but still does weird things with vector 3. But we'll get to that at some point, I'm sure. But yeah, I would be surprised if GLM is padding its Vec3 to match with uniform, but I could be wrong. I suppose you could go and just do size of GLM Vec3 and see what it says. Okay, so at the beginning of the frame, we're going to we're going to basically do this, where we're going to take a light buffer, light buffer, and then we're going to put into that dot ambient equals scene dot ambient, and then we're going to do buffer writer into the light buffer. I think I've overloaded my terms here, but it's not the end of the world. And then we're going to want to do writer dot write. Well, this won't work because the buffer doesn't support single object. The writer doesn't support single objects. We'll add that in a second. But basically, we're going to stuff our scene data into a struct that is specifically packed to work with the graphics card. We're going to then write that struct directly into the buffer, which is on the GPU, and then we should be free to bind it. Yeah, so that's what we're going to do. So alignment is basically just says how many bytes are there between subsequent elements of the same type, effectively. So OpenGL says that between each vec3 there should be 16 bytes. A vec3 itself is 12 bytes, so that means that the difference, which is 60 minus 12 is 4, is the padding, which is the extra bits to kind of make it align. It's just because something hardware access faster if it's 16-byte aligned. I wasn't there when they set out the spec, but I'm assuming it's probably to do with some access patterns and cache lines and all that other good stuff. So let's just quickly modify buffer writer. What we want to be able to do is we want to say template. What do I want? Is trivial? What's the one which is safe to mem copy? Is trivially copyable? Yeah, so I want template stud is. Oh, is it not a concept? That's annoying. Is there a concept for it? C++ is trivial concept. Is it just is trivial? It says it's deprecated. Because that's a type. That's fine. Okay, fine. Whatever. We'll let's do this. Go up. T and const. So basically going to say, if I'm writing a single object, we will do stud span const auto span equals stud span. Is that going to make a copy? No, it's not. Const t obj1, and then I should be able to just do write span. Oh, loads of comments coming. Sorry, I was lost in the world of template template programming. See, I can't remember if I used to trivial or not, but it's fine. Yeah, I guess I could just do it with requires. I just prefer to just be able to replace class T with what I want. Requires stud is trivially copyable VT. That is almost certainly not the right runes for that. Must prefer. Okay, fine. Basically, I only want to accept a T that is trivially copyable, which means it's safe to mem copy. So it doesn't have like virtual methods. It doesn't have like with inheritance. Well, actually, I can tell you what it means. It is. Not potentially overlapping subject objects, safely copied with some memcopy or serialized to and from a file. So basically, this just means that it's safe to kind of do what I'm, what is effectively probably going to be well, not a memcopy, but a GPU kind of memcopy internally. I think we got there in the end. Right, let's just see if that blends, because it's almost certainly not going to. Why don't I have a tree setups for shaders? Because this is the first time I've written shaders in NeoVim and I've just not got around to setting it there. I probably just need to go and find one and add it in. No appropriate default constructor available for renderer lines 31. Oh, because I need to give it a size, don't I? Renderer, and then so this will be the light buffer, and this will be size of light buffer. Okay. So that's not what I was envisioning, because I've not changed the color yet. So I'm probably reading from undefined memory, I'm not quite sure why it's doing that. I suppose we could just trace it back. I guess because I've not set it. I think the syntax I'm using is correct. Requires has there's a couple of different ways you can use requires in different places. So the fact that it kind of blends, I'm kind of happy to keep it. I need to bind the buffer, obviously. Thank you. I'm glad someone's paying attention. I'm gonna get that on a t-shirt. So where do we bind the camera data? Yeah, right. Okay, fine. So now we can do. Let's move this up. And then put this here, and then we'll do to 0, to 1, and then FC will do white buffer. I was on the line. Just it's been a long weekend. So perfect time to make a fool of myself in front of strangers. Why is auto everywhere? Auto's the best. So it looks cool. I like how it changes with my view. I know I've definitely not shoved it into the scene yet. So let's do, where do we set up the scene? Scene, and then we're going to, so we've got the entities, and then dot ambient equals dot r equals, let's go for our favorite. A nice azure. What do I use for debugging? Unfortunately, just like willpower at the moment, but I suspect at some point we'll probably have to break out a debugger. I'll probably use x64 debug. This is still not right? Like, it looks cool, but... Alright, let's just trace it through. So, scene has an ambient color. That should be F. Scene has an ambient color. Renderer has a buffer for light buffer. Renderer has a hopefully correctly aligned light buffer which mirrors the GPU, which has the color in it. A color itself is just RGB, right? We construct our light buffer and smash into it our scene ambient light. We create a buffer writer. We write the light buffer object to it, and then we bind it to uniform buffer slot 1. And then the fragment shader says, I put the one in the wrong place. Ah, what? I get it. I was using binding 0, which is the matrix data. So that means I was using part of the camera data, which is why it was changing with the viewport. That makes sense. It's nice when things make sense. Okay, right. Now we've got a nice blue light. Dull, dim blue light. Okay, right, so let's go back to our scene, main, and then we're going to change this to we're going to keep like a low light because we want to be able to see the effects of the lights we add, but we also, you know, don't want anything to be pitch black if it's not within the influence of the light. So let's just go like 0.3. Okay, so now we've got like a dim light. It's not particularly exciting. Right, so now we want a directional light. So this is basically, imagine a directional light is just an infinitely large light sort of infinitely far away, which just, you can think of it applying like loads and loads of rays of light in parallel. Basically, the sun is a directional light. It lights everything evenly from a fixed angle. So that's what we're going to try and add next, which means we should get some sides of the cube are lighter and some sides are darker, and that will kind of actually hopefully add to some sort of sense of like realism to the scene. Yeah, we've been using render.doc before when I've made mistakes, and we will almost certainly need to use it again. What about my code style do you not understand? Because I'm happy to explain myself. Okay, so lights. Let's go back to scene. We'll do the same thing again. So this time we're going to have 3 hash include vector 3, and then 16 we're going to have do we want to, I guess it makes sense to keep them combined, so let's do struct directional light, and this will have a vector 3 position and a color, and then 22 will have a directional light, directional. Const was great. Gotta love const expr. C++26 going to get hopefully going to get const expr exception, which I'm really excited about. That's gonna be fun. Okay, the reason I bundle these is up just because it doesn't make sense to have these separate. So I kind of want to force someone to at least think about, and by someone I mean me, think about making sure they supply both those at the same time. And that shouldn't be position either. That should be direction. We're using all the modern C++ features here, every single one, whether we like it or not. It's going to be a lot of ranges, In fact, there's one there. Okay, so now let's do dot direction equals dot direction equals, so I want it to be, I guess, kind of pointing downwards. So that's going to be, you tend to specify the direction vector in the way you want the light to go, even though a lot of the maths requires you to have it in the way the light is coming from. So we'll just negate it in the shader. So I want it to be looking into the screen, so that's going to be negative x. And when we're looking left, I think it's going to be minus 1.0f, minus 1.0f, minus 1.0f. I think that's kind of, if you see me at the camera, it's kind of over my right shoulder downwards. It's looking in the negative x-axis and the negative y-axis and then the negative z-axis, which is into the screen, right? Is that right? Right hand rule? Yeah, sure. I mean, it sounds good. And the color will be .r equals .f dot g equals. We can tweak the values later. I just want to get something going. Equals 1.0f. I think that's right. We will normalize it in the shader because it's easier, but I agree we should probably technically normalize it in the code, but I just can't bother to add a constructor at the moment. We'll just kind of keep it into the shader, and then I know you're kind of paying the cost of that normalization every frame, every fragment, but just it's going to keep it simple to start with. Like I'm not optimizing at the moment. But yeah, good point. That does need to be normalized. So I'm just going to keep this simple. I'm not going to do like nested structs in the shader. I just want to keep it simple. So direction and vec3 direction color. Of course, we're going to need to get some normals in there now. You should definitely use stood string. Yeah, exactly. I think there might be a couple of streams where we just do iterative optimizations when we're there. Like, I think we should just get something working first. Okay, so let's have a look again at our mesh class, which again is currently somewhat hard coded to a cube. We have in our vertex data the concept of a position and a UV. What we also need now is a normal. So we need to kind of know where, like, what way each vertex is facing into. I'm going to say world space, but I will almost certainly get that wrong. We need to know, like, you know, which way that is facing so we can do light calculations, because a directional light effectively just calculates the amount of light from that direction hitting it. So it's just a dot product. The further away it is facing from the direction, the less light hits it. And other maths words. So where's the oracle? ChatGPT, generate me the vertex data for rendering a cube in OpenGL with an element buffer must have position, normal, and UV. See if it gives me better UVs this time. Evening, Sam. More, yeah, you love it. More bulk formatting incoming. We're gonna. It's basically what we do. Like, this is just formatting. Okay, so it's finished thinking about it. Everyone's favourite part. There's an ad coming for Twitch, so you can just sit back and relax whilst I do all the formatting. Oh, it's still thinking about it. I think I'm going to do. Well, I'm going to use async. So spoiler alert, I'm going to use async. So it doesn't really matter what I use. And then I normally just disable all the importers that I don't need. So whatever free model I find online, probably an FBX, I'll import there. I'm not writing my own parser for a file format. I think it's just a huge amount of effort for very little gain. So what I suspect we'll do for an actual game is come up with our own like packed format, which kind of we can just like we can just splat straight over some structs, and then we'll have some part of our pipeline. We'll have we'll have a bunch of scripts which will just take all our models and pack those up, and then we'll just bundle that in as like a single resource. So there won't be any custom format passing in the actual library itself. We'll kind of do that. We'll do that work before the packaging up of the release. I mean, Async is what it is, and in theory it will work. I've used the thing. It's one of those things where I've used it before, so at least there is some kind of like prior art or prior knowledge from me. Yeah, like a pat file, be a custom thing we'll make. I appreciate the offer of someone else's object parser, but I'm just going to use something that I know works off the shelf, I think. Yeah, we can binary serialization for the objects and the textures and the game files and the scripts and all that kind of stuff. We will eventually pack everything up, and then we'll just basically ship the game with like that one file, and maybe even embed that directly in the executable. But to start with, we just need something to get us going with. Yeah, well, the thing. So I agree with you. Async does take a long time to compile. You can tweak it in CMake to not include the bits you don't want. So if we're just doing FBX, you can basically disable all the importers and then just compile Async with the with its FBX plugin. Yeah, it's one of those things where people sort of have weirdly, like, not weirdly. I understand people have a preference on. So if your preference doesn't align with what I want to do, I can only apologise. All right, let's go. No, let's do. I think we're doing this as a macro. Actually, I think it makes a lot more sense. So QA in dot position equals that f replace that, then do a dot normal equals that, and then do f in there, and then and then do a dot uv equals that. Go to the end, put in that, and then do Q, and then hope for the best. Could even have worked. Could even have worked. It's impossible to say. I didn't explode, so looks good to me. Sure do look like normals. And just check that the indices match. 0, 1, 2, 2, 3, 0, and the last one 22, 23, 30, 20. Right. I think ChatGPT has given me the same set, so we'll see how that goes. Okay, so that should blend. I don't think the indices have changed. 0, 1, 2, 2, 3, 0, 4, 5, 6, 6, 7, 4. Oh, I feel like a number station. 8, 9, 10, 10, 11, 8, 12, 13, 14, 14, 15, 12, 16, 17, 18, 18, 19, 16, 20, 21, 20. Yeah, they're the same. How's everyone Sunday going? Tuned in to someone read out a list of numbers? So I now need to do this and set this to this, and then go to this and go F0 R1, FP normal, K F1 R2, and then do out vec3 norm. I already hate my naming convention for this. Norm equals norm, and I absolutely hate. I guess what I should do is maybe preface these with in and then do in position, and then I can have output as normal, and then do normal as in, and then in. Yeah, the UVs will still be wrong, but oh well, part of the fun now, isn't it? It's part of the fun. Dynamic code-based mesh generation on the cards. I doubt it. Not for this. I'm trying to keep it simple. Everything I do, I have to ask myself the question, does this get us closer to a game? And there might be some sort of gratuitous extra bits that I want to do, but by and large, that's what I'm trying to keep in my mind. Okay, right, so let's go to the fragment shader. We've now got our in vec3 normal. I know you need a normal matrix to properly scale them in the event that you have a non-uniform like scale. I'm not going to do that today. It's just probably too much maths, and I'm just going to not hit that edge case. And then what will happen is we'll get like 3 or 4 streams time. I'll scale something non-uniformly along one axis. It'll all look terrible, and then I'll forget why. So to answer that question, before anyone, I'm sure people know. I'm just going to keep it simple. I think we could just check this works still, like with the normals, but everything's still working. That's not worked. Oh, that's terrifying. There's sort of this dark, creepy, sort of like spindly bits. I thought I adjusted the buffers. Nope. I did not. Well, I sort of half did. Still not there. So 3 floats, 3 floats, 2 floats, 0, 1, 2. Oh, got to enable it, haven't I? This is why you need vertex pulling. Maybe one day. Okay. I feel like these are bigger. They weren't this close together before, were they? Surely, has ChatGPT gone and changed the size of my cubes for me? Am I getting? Okay, can someone confirm to me? They were not that close before. Oh, I think these are all ones. Okay, fine. Let's just. Where do we set these? I want to just make them a little bit more spaced apart. I suppose I could add a scale matrix to the model, but I've not implemented scale matrices yet, and I know it's trivial to do, but later, soon. Right now, I'll just fudge the magic numbers that separate them out. Okay. Where are we at? So we need to go back to the renderer. We need to go 21G and then bang, and then what was the order of it? Ambient, direction, color. This needs to be a vector. I really hate the way that ClangD is like, oh, I know you need to include a header file for this, but I'll preface it with source slash. I'm sure I can configure it to not do it, but not today. And again, it's a little bit wasteful to copy the data into this local struct just to write it to the GPU, but I think this is conceptually simpler and easier to kind of debug and see what's going on. And then again, we can optimize it later. What I suspect we'd actually want is some sort of dirty bit in the scene. So you would just write this light buffer once and then only update it if any of the light parameters change. Because that way you just sort of taken all the light data for the scene, shoved it into the GPU, and then you don't worry about it unless it mutates. But for now, we'll keep things simple. We'll just do it once per tick. So this will be scene dot directional dot direction, and then directional color equals scene dot directional dot color. And then we just write that as one block over to there. Let's just check that still blends. Then we can get onto some of the maths. Yeah, you could. It's a good point. You could persistently write the buffer, persistently map the buffer. I'm never really sure like when the best time to do that is, and I think I could be wrong, but isn't there some sort of synchronization shenanigans you have to do if you've just got a pointer to what is under the hood mapped to GPU memory? Oh, I know it's padded. That's the following warning is treated as an error. Structure is padded due to lines. Yes, I know. That's exactly what I want. Why are you? What a weird thing to give me a warning about. I'm not sure what game we're making yet. I'm just trying to get lighting working to start with, but we'll do something. We'll do something at some point. It'll be simple. It might just be a recreation of an existing game, or maybe a slight twist on it. It's going to be something pretty basic, but just to kind of go through I really want to go through the full end-to-end of like from nothing to a game, including like sound and settings and menus and save games and all that kind of UI and all that kind of shenanigans, like all the extra stuff that comes after just trying to get a light to work. I'm really not understanding why this is issuing me a warning. Like, this is exactly what I want. This is the exact outcome I wanted. I wanted the padding. Am I going to have to ignore this warning? It looks like it's an MSVC thing. We could pad it ourselves, which I don't really like the idea of. Right? Yeah, I just have to disable this. Yeah, the problem is I can never remember what the runes you need to draw in the sand to appease the Windows compiler to disable this. How do I... So, MSVC disable warning. Disable single warning. It's going to be a pragma warning. There you go, right. 4324. So we're going to do... This is grim. Pragma warning push. Pragma warning disable 4324, my favorite. 324, and then and then pragma warning. I hope I can do it there and not at the call site, but I suspect gosh, horrible feeling I'm gonna have to do it at the call site. Doesn't matter. We've appeased the compiler. Okay, right. So that looks pretty much the same. this just looks grim. Like if you this is obviously not usual C++, but if anyone was coming along to learn it and they heard about structs and they're like, oh, look, I have an example of structs, and they saw this, you'd be like, I am out. It is a bit dark because we haven't finished programming the lights yet. Right, so directional light is the dot product of the normal to the light direction. So let's do this. So let's do vec3 ambient. We'll call it amb because I think these are global terms. Amp color equals that, and we'll get rid of this. No, we won't. 3 or 4, and then we'll do vec4 dir color equals tbc to the dot, and then the frag color will be amp color plus dir color. Now I just got to finish filling this bit. Yeah, we'll invert the we'll invert the light direction. Well done. If you give the uniform a name after the closing bracket. Oh, interesting. Okay, is it just because I've vomited it into the global namespace? But that's fine. Well, giving it a name there. Does it need that name duplicated there? Is it kind of like a weird like C struct type def issue? Anyway. So vec3 light dir equals normalize. Oh, what is this? What is this? Minus direction. Okay, cool. Thanks. So we'll minus direction. Then the diffuse color will be the maximum of the dot of the normal to the light dir 0.0 oh, hang on a minute. Whoa, what are we doing? Diff float, and then we'll do vec4 and I know this says dir no, that's right, yes, dir color equals vec4 diff 1.0. Oh, and then we need, is that right? Oh, actually, no. What am I doing? It's vec4 of diff times direction color. That's what we want. I'm always winning. Okay, so basically we want to take the angle between the normal, so the point, the vector sticking perpendicular out from the fragment that we're shading to the light direction, and then that will effectively become the scalar for the amount of light that we want to return. There is a point where you might end up with a negative number because of the way the maths work, so you just effectively clamp it to 0, and then we take this diff, which is effectively a scaling factor, times it by the color of the light that we put in, and then we just add that to the ambient color. I mean, what could go wrong? Let's just let's check it builds first. Okay, our first poll of the night. Do we think we've just got directional light's working straight off the bat, like first time. Light. Light, question mark? Light, question mark? Yes. No. Start prediction. Got it. This is such a great point for on YouTube from WGG25, which I keep reading as like a ISO working group, like WG25, because isn't C++ working group WG21. Anyway, if it goes over 1, it'll be clamped, and you effectively lose all that extra light data. To capture that light data, you need to use HDR, like high dynamic range. You need to use a floating point frame buffer, which you can then allow you to store data values that go beyond 1, and then you have to tone map them to bring them back down to the LDR range. This is something I want to do in the future, but yeah, at the moment it will just top out at 1. Right, let's go for it. I think that's right. I think I've just got the vector the wrong way around. No, that's definitely not right. I don't know. Is it right, or am I second guessing myself? I just no. Is it right? I just all. Is it because the vector is perfectly going through the corner from one corner of the square to the other? All these 3 faces are evenly lit. You know what? It's an easy way to test this. Let's go to main. Let's bring down the brightness of that light just a bit. So let's go 0, 5. No, if not. Oh my goodness, I cannot type today. Like even less so than usual. Where's my code even gone? R5, and then let's make the direction point just down the x-axis. So let's just make these 0 and 0. You can't really put the light source in the center because the directional light doesn't have a position, it just has an angle. I think my camera is rotated wrong to start with, but I could be wrong. Because I am not looking down the z-axis. Yeah, you're right, yeah. I'm not using... Oh! I think someone makes a good point. I'm gonna put this as a yes, by the way, for the people. I think yes light. Do I need to blend in the texture data? I think I do, don't I? So it should be light diffuse times diff times the texture data, right? Is that right? Yeah, I'll save it off in a variable in a second. I just want to just check that works. Ah, that's what I wanted. Look at that. That's better. I saved that variable and didn't use it. No, I used the amp color here. That's why I bring them all together. What I need to do is do vec for sort of, I don't know, source color. That's a terrible name. I guess it is the source color equals texture text vertex chord. And then I didn't think it looked right. Do you know what I mean? Like it just. Oh my goodness. Source color, and then let's go to the next texture, and we'll do the same there. Oh no! Oh no, we will not. Albedo, that's the one I'm looking for. Thank you. %s. %s. Source. Color. Albedo. We're the relentless march towards the game. We're getting closer. I'm going to make those 1. I'm not convinced my camera is right. I'm more inclined to trust OpenGL's concept of where the axes are than my terrible maths. That's better. That's what I wanted. Right, I think there's some more corrections to be made. There's lots of ways I can refactor this. I'm kind of just iterating on it just to make sure I kind of get the maths going. So, normal is in local space, light is in world space. Yes, good point. So I need to also modify the normal by the model matrix as well, right? And then what you should really do is also multiply by the normal matrix, which is the, what is it, the transposed inverse of the 3x3 subset of the view matrix, or whatever it is. But I think that should get us going. Someone else has pointed out a mistake. Where are we going now? Vec4 in normal. 0. Here, right, yeah. And then will that automatically cast it down to a Vec3 for me? Or do I have to explicitly do that? I suppose I could just swizzle it, right? Yeah, I've swizzled. Oh, what have I done wrong? Failed to compile vertex shader. Where's my mistake? Oh, hang on. I know why. Don't say it. Don't say it. Swizzling the wrong thing. Gotta be careful of that. It's dangerous. Get hurt. Oh, that's better. Alright. Oh, and actually, now the light is the direction I expected it to be, because we had the normal in the wrong space. Whew. An hour in, got directional light. Nice. Okay. Let's do, so there's kind of, I guess the facets of this that we need are directional light, point light, and then also diffuse light and specular light. So yeah, I'm thinking point light first, because we can make it interactive, because we should be able to rotate the point light around. Then we'll go back and add the specular. Yeah, we'll put a point light. Well, I don't want to put, I think we might put it off center and then maybe rotate it around the origin, just so we can kind of see that updating in real time. That's my plan. And what a great plan it is, because it's been going so well so far. Back to scene. Struct. Point light. Reach my follower goal on Twitch. That's exciting. Thank you very much for everyone who's following. If you have not used if you have a Prime subscription and you've not used it yet, always appreciated. But obviously you don't have to, and that is also absolutely okay. The fact that you're here is more important than anything. Right, vector 3 position, color. I don't think that's too controversial. It's fine. I have more people on YouTube. More people tune in to the lives on YouTube because I think that's where I grew the audience from. But it's absolutely fine. I don't really mind. I think the fact that you can kind of dual stream is great because I kind of get the best of both worlds. Oh, whatever this hot mess is, right? Okay. Oh no. All right. Dot point equals dot. I believe it's the position first. So we'll stick it at the origin to start with. Well, I'll put it slightly above, I think, for funsies. 0.0f, 2.0f, 5.0f, 0.0f. The website I'd recommend for this is learnopengl.com. It's probably like the canonical guide to like OpenGL 3.3. We're doing some stuff that kind of bit beyond that, and I do want to push it a little bit further. But a lot of this stuff I'm doing now, I've pulled from that site in one form or another. Color equals. We're going to do dot r equals 0.5 f dot g equals 0.5 f dot b equals 0.5 f. I think that's right. I think the reason to store it in... So the question was, why do we store shaders in a file rather than line in the source code? I guess ultimately it doesn't really matter. If we store them in files, then we can always add hot reloading in the future. So the idea is we change the shader file, resave it to the disk, the game detects that it's changed and can automatically reload it and update the scene. So that's a possibility, a possible advantage. Whether we'll do that or not, I don't know. I'm not really a web dev, so I don't think I'll be able to provide much help with the website, I'm afraid. Okay, so now we're going to vec3 position, point, and vec3 point color. I know there's like attenuation and all that kind of stuff. I'm probably just going to hard code some values to start with, and then we can kind of push that through in the future. So, renderer, I think. Sounds like a good place to start. 26G, what we'll do is we'll have two of those. We're not going to call it direction, so this will be point, and then point. This still writes it, and then we just do dot point equals scene dot point dot position, and then point color equals scene dot point dot color. Right. Suggest. What are you complaining about? Vec3. Okay, so that should, let's just check that still works, still blends, still happy with it. Okay. Still got that. Okay, right. So now we're gonna wanna do the, just wonder if it's worth splitting this out into functions. So that vec3 calc ambient, which will take what we passing in the vec for albedo. Oh no, actually, I think Stuprint and Stuprint might be one of my favourite new additions to the language. It's just made just like outputting stuff so much more enjoyable than std_c outstream. I know this looks a bit gross, but let's just try and keep it consistent. So let's do vec3 calc direction. Oh my goodness, that's a lot of those. And then the inputs to this vec3. I've not really thought about this. I'm just feeling it out as we go along. So the light dirt is the normalized direction. We take that, and then what I'm going to do is, as someone suggested, we might as well just do the multiplication once at the end. So return FE like that. So we have the albedo, we have the amb color equals calc ambient. We have that ambs. We have the direction color equals calculate direction, and then we do frag color, so 37GF equals BBB, CTD, and then we do, oops, sorry, times albedo XYZ RGB vec for 1.0. I think that's right. Well, I mean, I think that's what I want. Oh yeah, good point. We're going to optimize this later. At the moment, I'm just doing it per frame because it's easier. We'll cache it. We can do all this sort of caching later. I'm not quite sure exactly how I want all this OpenGL code to look. So at the moment, I'm just kind of doing what gets this forward. But yeah, it's a good point. Like calling this every frame is a bit, but isn't great. But for what we're rendering, it's absolutely fine. Right. So now we can do vec3. I'm gonna have to put the I position in there as well at some point, right? Calc point, or is that just for, that might just be for specular. So then we can do FD, oh my goodness, BCT point, and then FD point, and then plus point color. Flat map got approved in C++23, but as far as I'm aware, no one has implemented it yet. I don't think any of the three compiler vendors, or I guess standard library maintainers, have implemented it yet. Modern C++ is kind of by design. They're adding more to the language so you can kind of write less, if that makes sense. A lot of it is designed to have like simpler and faster and more efficient features. Have I Oh yeah. That's not what I wanted. Okay, am color, dir color, point color, count point color, direction. Okay, CP Clang has partial. I've not used it yet in any compiler just because I didn't think anyone supported it yet. So you can always use boost. I mean, if you're desperate, you can use boost unordered hash map. I think that's considered pretty good as like a pretty good sensible default these days. But I just tend to use unordered map because it's there, it's easy. You have to do a bit of work to get the heterogeneous lookup, which is a bit of a shame, but it's okay. Okay, so we're gonna want the fragment position, right? How do I get the... So... how do I get the fragment position in? Do I have to explicitly output that? I think I do. I don't think there's a special... Is there a special variable in the fragment shader which gets the fragment position? Hold on one moment, caller. There is. Wait a minute. I asked a question with 2 parts and someone said yes. Yeah, I got... Is it... Okay, fine. Can we just use geofrag But NDC. Oh, it's in normalized device coordinates. Okay, fine. So I need to do out vec3 frag chord, and then is that just then? Do I then just do frag chord equals GL position? Is that enough? Will it do the correct interpolation? I think that's right. We'll soon find out when it's not. For point light, your light will be in world space, so the fragment position will also want to be in world space. So... Yeah, but someone's saying GL chord is in normalized device coordinates by that point, which is not what we want. You're right. We need it in world. We need the fragment position in world space. I think that's right. Oh, sorry. Yes, you're right. Take the interpolated position of the fragment, convert it into world space, bang that in frag chord, and then bring it over here. In vec3, vec4, frag chord. I assume that's also going to be a vec4, and then this will have to be vec4. Sorry, vec4. Naught. That's a lot of text, Quaco. I'll pass it in a second, but I think this is what we want to get forward, right? I might do a deferred shader if we need more lights than. For the game, if the game demands more lights than we can feasibly do with a forward renderer, I will do a deferred renderer. But at the moment, we don't need it. Okay, 1. Oh, man, I'm glad someone's here because like if I was just doing this by myself, I would just iterate through this and I'd eventually get there. But it's nice to kind of short circuit it when there's people who actually know what they're doing. Yes, okay, frag quarters in window space, geo position in clip space. Okay, right. Lots of spaces. Lots of spaces. Now I want the maths for this, so this will be vec3 light dir, which is the normalize the light point light minus the frag chord. I don't like frag chord. I want frag position. I know it's kind of, I don't know, might seem strange, but a bit pedantic, but I've already got text chord, which in my mind means something else. Okay, so minus the, because to get the vector between A and B, you do B minus A, so that will get us the vector between the fragment position and where the light is. So from the fragment we're shading, the vector from there to the light. Then we want, again, the diffuse part of this, which will be the max dot it's the same thing, right? It's you're using the dot product to work out how much light is being applied to it, but you're now doing it from the point of light to the from the fragment to the point rather than to some sort of uniform vector coming down. So it's very similar math. So the maths is actually very similar. I was getting confused with the specular stuff, which then needs the camera or the eye position, because the amount of light you the specular is basically a function of the amount of light you can see from the angle you're looking at. Okay, so that should give us the diffuse. So I should be able to do return diff times point. Cut. What are we thinking? I've not attenuated it, is the only thing. I can't remember if I need that for diffuse or not. Because otherwise the light will be... I'm going to need to attenuate it, right? Otherwise the light's going to be infinitely bright from that point. It needs to drop off. That's the whole point of a point light, is you have drop off of the light. I divide by the distance, as in the final product. I divide by the distance. So that's diff. So diffuse over. It's the, how do you get the mag? Is it length of light of point minus frag position? I can't remember the OpenGL rune, but this will drop off this by the side by the strength of the light, right? Let's give it a go. Did not like that. Failed to compile the fragment shader. I need to put in the extended shader info. I've just not had to do it till now. I was really right. Quick look to see if I can figure it out. Otherwise, I'll go through the motions of getting out the actual compiled error. Oh, that's not. I've got too few brackets there. Right, okay, fine. Let's just find, let's look at how to do it. Someone sent it. Oh, do I need to? Am I missing a swizzle? We'll just right. Okay, fine. So shader. We get the shader result, and then get the compile status. If it's failed to compile shader, so if result, if not, so if result doesn't equal 0. Put that there, and then we need to do char log 512, and then we do OpenGL, another function. FB, what else is going to be GL get, hang on, GL get program error get program info log, get program info log. Do GL get program info log, and this takes the shader program, which will be the handle, the size of log, a null pointer, sure, and then log itself, and then we can just do and then, sorry, I see people are chatting away. I don't know if someone has seen the issue. I'm going to bung this in the exception message. Have I got the wrong flags? GL get shader info log for compile status, program for link validate. Oh, I see. Thank you. GL get shader info, GL get CTI shader, and then over here that'll be the same there. Good spot. GL get shader info. Save the file, classic. Managed to get through an hour and a half without making that mistake. Okay. Oh, the shade. Wait a minute. The shader has compiled. I'm getting, this is from the OpenGL debug log saying program has been linked or It's not throwing this. What do you mismatch variable names where? Because this is not. I see, yes. I see what you mean. Out vec4 frag position, in vec4 frag position. That's the only one, right, that I've added. Because we had normal and text chord before. The file's not saved. We're just going to ignore that. That file wasn't saved. We're just going to ignore that. Okay, fine. Another issue. Program has not been linked or is not a program object. So am I failing to... It's failing to link the program, right? So that means there is... Okay, fine. Let's go back to shader, and then we'll go back to OpenGL, and then we will duplicate this and do get program info log, and then CTI program info log. So basically say check the compile status, and then yank 40G, and then we'll do check the link status, then we'll do get shader CTI program info log, and failed to link shader. Okay. Someone thinks they found the issue, but that's just... we should set all this up anyway, and I should have done this at the beginning, so we're going to need this anyway. Okay, fine. I don't understand. And get shader, like... I assume this return, these are zeros, right? Returns GL true. Have I just got these right around? So if this doesn't equal GL true, right. And this needs oh, wait a minute. So this needs to... Okay, fine. Material. Yes. Well done. I think someone's seen part of the issue. Here, this should be... Here. In fact, we don't need to scope this anymore, because we can just reuse that, and then this will be like that, and this will be like that. this is going to work. I say work. This is going to give us the error. No, it's not. It's not going to compile. Material line 31. Fail to link program. Let's just be specific. I know someone said it, but we can. This is it. Okay. Where's this implicit cast? Is it here? Or are we just missing a swizzle? I didn't even get it that time. So what's going on here? Yeah, I think. Oh, so this has to be get program IB. Okay, fine. Oh man, a lot of like miserable low level like filly stuff today. I do apologise. We're supposed to do lights, not fill around with this. Oh, well, it worked that time. I say worked. I don't feel like I've got any kind of drop off in the light. Right? That's not right. We should expect to see like a glow of more lit ones in the centre. What have we gone wrong? Where have I... Larger. So I want a larger intensity in the point light. Oh, genius. It's like a real game. Look at that. Is that right? I feel like... Why do I feel it's lighter... I knew it to point to the screen then, which is absolutely useless for everyone out there. I feel like it's darker towards the camera and lighter further away. Oh, shadows. We are some way away from shadows. I've implemented shadows before, and shadows is one of the biggest lies in games ever, and it's an absolute massive pain. So we'll do it at some point. Yeah, why is that? Why are these ones not lit? If I come over here, why are they? Can anyone else see that? That's not right, is it? But at a glance, it's right, but like it's definitely. If I got a space issue, like a view space, it's behind the light. But the light is uniform in all directions. It exists somewhere just above here, right? Maybe normals. No, it can't be normals because it must be something to do with the frag pods. Well, it's dependent on the camera, right? So if the normals were wrong, then it would always be wrong. But the fact that it's only wrong in certain positions of the camera, like I'm just trying to deduce where we're at. Let's When you're under the world, you're only seeing the back faces for the quadrant nearest the camera, and all three back faces are unlit. On the other side, three quadrants, you see at least one lit face. Is it because of the direction light? I don't know, there's a lot of... Let me turn off the directional light, in case that's... There's some people... There seems to be a split opinion. Some people say this is correct, and some people say this is incorrect. I think it's incorrect, because it doesn't look right. Like, that doesn't look right to me. The further cubes look brighter because you see more of the sides opposite the light from the closer cubes. But well, I mean, there's no ambient, there's no like diffuse shading, right? None of these boxes emit light, unless it's just you're suggesting it's just like an optical trick. Oh, I see what you mean. I'm just looking at the back faces of these unlit ones, and I'm seeing more of it. I see what you mean. Yes, I think WG25. I think you are right. I think you are right. I think I'm just looking at the back of the boxes, which then sort of as the light accumulates from my eye forwards, obviously I'm going to be seeing more reflected light from those boxes. So yes, I think you are right. I don't know. I'm not an expert in this, but like I hope you can kind of understand why this looks strange. Let's bring back the directional light. Let's move this light out and see if we can remember how to do all the maths that we did to rotate the camera. So let's do static auto t equals 0.0f, t plus equals 0.001f, scene dot, oh, why can't let's make it mutable, scene dot, hello? Dot point dot position dot x equals stood sine of t time plus 5.0 f? Or was it times? How did we do this last time? Sorry, that's me trying to use the English way, British English way again, with maths rather than math. Times to scale plus to offset. Yeah, so I want to scale it. Oh, it's not even math. Sorry, this is a school error. This I'm just reading C math. Sorry. That's just too small a change. We had this problem last time. There we go. Hopefully people can see it moving. Yeah, it's all taken care of. The first thing the render does is build its buffer. What I might do is I'm just going to, it's kind of tweaking a little bit, I'm going to make that wider and make this faster. Look at me go! That's pretty cool. It's quite hypnotic, actually. I like the way this sort of the sides here kind of sort of pulse. Okay, so that's that. We've got a little bit of time left. I mean, that's a pretty good place to end, but I want to go for a little bit. I want to go for a little bit longer, whilst I have everyone's attention. Is the light shifting? No. Okay, fine. I'm just going mad. I would quite like to give specular a go, or at least start doing it. We might not finish it. That is just a little bit too fast. I want something kind of in between that and what we had before. I feel like I'm kind of playing for time. There you go. Nice. Okay, so this is just diffuse, so the reflected light is purely just a function of the distance between it and the light source, or like either the direction or the point in space where it's at. Specular kind of makes it look shiny. So we're going to give that a go. I might just do specular on the point light, just because I think it looks better anyway. And then we can add it to the direction later. So it's effectively, it's like the amount of light that gets reflected is then a function of like the angle you're looking at, if that makes sense. It'll make sense in a minute. So what I need to do is I think I need to bash into this somewhere the eye position, I think. Or maybe not. Maybe I can just do it from here. Let's see. Reflect equals reflect minus light normal. So the amount eye position is needed. I thought it was, yeah. look up how's this calculated. Speculate. Okay. Yeah. Yeah. I've heard that trick before. If you put all your variables in camera space, and then the origin is just your eye position. Yes, you can grab it from the view matrix. Isn't it like the 13th and 14th member of the view matrix? Is that right? So we need the view direction, don't we? Which is the camera position. That's right. Okay. So calculate the reflected light, and then float specular amount is the I'm just checking some notes, by the way. I'm not just divining all this from memory because I have done this before, but quite a while ago. The max dot of the eye, which we don't have at the moment, to the reflect, and then we clamp that to 0.0, and then we raise it by some sort of shininess. I believe 32 is a good kind of go at it. And then I want to add this to here, right? Thank you. Door of the eye. Yeah, diff plus specular, because I still want them both to drop off, and then I still need to make that. So it's just the eye. So the eye, I don't actually have access to the uniform here, but that is easily solved. If I slap that in here, and then I think vec3i equals view. Whoa, where's my code gone? Vec3 view 0, 3, 4, 5, 7, 10, 11, 12, 13, 14. Is that right? Can I just pull out the view matrix? I mean, it could work. It could work. No, it couldn't work because someone said I've typoed it. It's a special variable. Do you not know the view special OpenGL variable? They don't tell you about it. It's undocumented, but it makes all your code work. View matrix. There's a lot to unpack there. What? Failed to compile the fragment shader. Oh, right. Okay, fine. So it's 0, 1, 0, 1, 2, 0. 2, 1. I mean, that's not what I wanted at all. Three? Nope. 2. Oh, sorry, the theme is Dracula. Yes, sorry, I thought I'd answer that question. I read it and I was like, oh, I should answer that. Is that shiny? I guess it's really hard to tell because the flat faces. I don't think that doesn't look any different to me. Like, am I getting mad? Let's make it a bit slower because that is too fast. Let's go back down to our really slow one. Remove the diffuse check. Good point. Yes, it's nothing. That's just the ambient light. So we've got 0. I think I want the third column. 0, 1, 2, 3. I think you're right. I think you are right. Math is hard. I've not done matrices since further maths many years ago, so I'm trying to have to really dredge that from my memory. Whoa. That's not what I wanted at all. Is my power too high? Do I need this to be like... two? This is real graphics programming, twiddling with the magic numbers until it looks right. This is what it's all about. Oh, that is just... it's just not right. I feel like we are really guessing now. Oh, I was just looking at it in render doc. Might just have to render doc it. Okay, that. So, but what I think I now need to do is put the power back up. Okay. Oh, that's a blast from the past. What's happened there? I thought I copied. Uh-oh. OBS just said it's disconnected. Is there anyone still out there? Okay, glad. Right. I don't really know why that... Okay, apologies. Some people had a slight outage. Open the game, loading assets. I literally don't understand why this is loading last stream's messed up one. I've literally copied it over. What's going on? Hold on one moment. Game stream. Okay. Okay, it's just put it in the wrong place. Okay, right, let's try it again. Launch application. Launch. Oh, am I actually... There you go, right. Try again. What is... I'm going to get grumpy with this. So, copy the source directory, which I built, to the GameStream folder, right? Which is here, source, game.exe. That crashed. Thank you for subscribing, much appreciated. Born Theory, thank you very much. Okay, what am I doing wrong? Launch application, game, in the source, load the assets. That's different again, isn't it? What's going on there? It shouldn't matter because it's loaded the shaders, right? Source, assets, container 2, updated. Right, hang on. Right. Absolute fucking waste of time. Right, there we go. Apologies. Got there in the end. So let's do F12. Okay, right. So got our inputs, got our outputs, got the buffer, right. So nice. Okay, so we're drawing this one here. Pipeline state. Got the. I think it's going to be. Got the NUVs. Got the 2 buffers. Okay. Fragment shader. Let's. I want to view the camera. Here we go. That's what I want to view. So row. So column major. I think this one then is... No, wait a minute. It says column major, right? So I assume each of these are rows, so these are columns. So I was doing these. So this X, Y, Z. I think, is that? No, because my camera's up, so the Y should be positive. But none of these look right. Can I not? Get camera. You know what? You know what? Let's. Just don't have to worry about it. Let's just. Yeah, that's what that's what I'm doing. I'm just gonna slap. Even worse than that, I'm just gonna slap it in a uniform. And that's going to be geoform 3F, and then. Oh, in fact, actually, no, that's. Where do I write the camera data? I could probably just write it straight into there. Oh, I'm making this way too complicated. Right. We're going to take that out, and then we're going to do vec3 I, and then we're going to do writer dot write camera dot position. Oh my goodness, does the camera not even expose the position as part of its API? Outrageous. Do that first. Camera, and then just going to take all this, and then we'll do direction, and that'll be position. Position. Go back to where we were, go back to where we were, go back to where we were, go back to where we were. Right. Camera dot position. I will also need to update the vert shader as well. Yes, you are correct. I don't have to worry about alignment either because the padding's going to be on the end and I've got nothing else after this. Obviously, if we add another member after this, I'll have to care about the alignment. Yeah, I might embrace the camera space. I think I need to think about that and like, what does that mean? Because my mind can't quite comprehend that like now, live, like changing all the view spaces and stuff. Invalid offcell size. Need to fix that at some point. I am does the buffer writer not have a bounds check on it? Outrageous, absolutely outrageous. We should definitely put that in there. Okay. This doesn't look right either. This definitely doesn't look right. I really like C#. I see some people discussing it. I think it's a great language. I really like it. Where are we going wrong? So we want the power, the max of the dot of the eye to the reflection dir. I strongly suspect I've got a view space issue again. Oh no, the camera is in world space, right? So that should be fine. Oh, do I need... because I want the angle, I want the function of the light reflected to be, I want the amount of light reflected to be a function of the angle between the eye looking at the fragment, not just the eye itself. I think. Good. Sounds good. Sounds good to me. Not convinced. Oh, it's this kind of shiny edge bit here is kind of what we want, but not like that. Okay, let's go through and let's just debug this. So the diffuse is the normalized position of the light from the fragment position, both in world space, and then the diff is the dot product of that. The reflection is the reflected angle from, so the opposite angle from minus light to normal, as in like you reflect light across the normal. And then the speculative power is the view. I'm not convinced. I think this wants to be. Is this just too high? It's just. Is it to do like? It's something to do with the view position, right? Because this doesn't look too bad. I mean, it's not right, but it doesn't look too bad. But it gets darker the closer I get to it. But it's not changing on the angle, right? So, I think you are right. It does need to be something to do. It must. It's got to be to. If it's to do with the angle, then that must. Oh, second guess myself now. I think it needs to be normalized. Normalize the eye foot to the frag position dot xyz, because it shouldn't just be based on the eye position, right? All right. I think I now lowered the intensity too much, so we now need to boost this. Got to normalize that normalize that eye. I feel like I'm not getting anything now. Well, it hasn't exploded outwards, so. Oh, of course, I need to add some sort of hard-coded shininess factor, don't I? Yeah. I don't know who. Every stream someone comes along and asks, "Is this pre-recorded?" And it blows my mind that, like, maybe one day I will. Ah, there we go. I'll just stream out a pre-recorded stream. So now we can add back our diff. It's really hard to tell because it's a flat object, but I think that's right. I think if we lower the diffuse a bit, it's half that. There we go. Right, I'm over time, but there's one last thing I want to try and do, and I think it could be quick, but we'll see. We'll see. Where is it? I want to see if we can add in this image here, which comes from OpenGL, which is a specular map. So it'll mean only the metal bit is shiny and the wood doesn't. And I think that will look a lot better. Okay, right. Main. Texture. Spec map. Resource loader dot load binary container. I've already forgotten what it was called. I think super chat overtime. Yes, let's do it. It's alright. Okay. This is one of those things where we do this before the end of the stream. One last chance to dance, and if I can't get it to work, then it'll be the thing we do next time. Right, okay. Now, nothing here supports multiple textures, which is great. So what we're going to have to do is really bodge this in. Let's have... they're all going to use the same sampler. Const. This should be a span. I'm just gonna super quickly just see if I can get this in, and then we'll refactor it next time. Okay, fine. So I'm going to take a collection of texture pointers, call it textures. I'm going to slam that in here. Then I'm just going to return a const reference to that. I don't like any of that, and neither should you. But something fun to do next time. Constant vector f star. And then textures, and then textures, and then vector const. So that's good. Main, that's main. We need our std vector of const game. I should do this with a range, but who's got the time? Oh, actually, I do. const auto text pointers equals no, I'm wasting time. Right, std vector const texture text pointers, and then we're just going to do address of texture, address of spec map, game, and then this will have textures. Let's check that was right. Okay. Yes, you're right. Text pointers. Okay, fine. And then renderer will go through these. So we'll do for const auto text in entity textures. Get rid of this. Ranges, and then I don't want that. I want for const auto text index in entity textures std views enumerate text dot handle index and then I want const auto uniform name equals std format text index, and this will be uniform name.cstra. Okay, and then up here we're going to have text naught, text 1, and then for the amount we're going to want to do 50 times texture text 1 UV. Where do I calculate? Yeah, text chord, and then this will be text naught. No, I don't have a strong game at all. I'm literally just making this up as I go along, and now I'm going to basically quickly fix the compile errors, watch it explode, and call it a day. Renderer, line 85. Have I got my enumerate the wrong way around? Maybe I can't take my ref. Oh, it's the index first. Great. Handle is not a member of text. You're right, it's not. It is native handle. It's not even that. Native. For the GL unit. Oh my goodness. It's gonna be every single one, isn't it? Okay, fine. Const auto GL index equals static cast GL uint index. Then index becomes GL dot. Ooh, steady. Implicit narrowing of vec4 to float. I mean, in the fragment shader, what have I done wrong? What have I done wrong? What have I added? What have I added? I've added this. Probably just want the R component, right? Because it's a black and white image. Well, it didn't work, I don't think. They didn't explode. But I was expecting the metal bars to reflect more light than the non-ones. Let's just drop this down a bit. It might be that the diffuse is too high. Oh, there we go. Look at that. Look at that. It's shiny metal. Nailed it. What a mad fucking rush that was right at the end. I've never written C++ so fast before in my life. Right. I'm going to leave that there. Well, I do. Actually, no, hang on. Do things. Where's the chat? I need to head off very shortly, so let me just do the usual admin bits. Where do I gift 5? If you're on YouTube, I can gift 5 10 random memberships a month, so there's 5. Good luck to whoever gets it. It gives you a few bits and pieces, which is nice. Let me just see if I can sort out a quick, see if there's anyone around on Twitch to raid, if it's worth doing. Same category. Just want someone doing C++. Use low to high. Cannot see anyone. Okay, probably not today then, but that's fine. That's fine. Okay, well, that was... Let me just leave that up there for people to see. I can't believe that we got that done in like 5 minutes. That was unbelievable. I was absolutely not expecting that to work. I will comment this up, but I'm going to do it off stream because I do actually have to head off now. But I will, don't worry, you can trust me to tag it or do it properly. But that's actually, I mean, it looks pretty realistic. It looks kind of like shiny metal. I think that's pretty cool. Things to add next time are specular stuff to the directional light. I want to tidy some of this up so it's not so hard code. I think we'll probably do a bit of a refactor stream next stream. There's some stuff that I'm really not pleased of. I think we'll just take a bit more time, a couple of hours just to go and tart all this up. And then we get on to, well, it depends. Got a choice after that. We'll either do, I don't have a normal map for this image. I guess I could try and generate one, or I'll just find some more textures. We need to do either model loading, or at some point I want to put in like a DRM GUI UI so we can like use sliders to like change the colors and move the lights around and stuff. But we'll see. I'll probably do model loading first because it's more pertinent. Yes, exactly. We're going to put lipstick on this pig and make it look pretty. I'm super pleased with that. Anyway, thank you very much for all coming along. I hope you had a good time. I've had a great time. been really productive. I'll catch you all in the next one, which should hopefully be Wednesday. Enjoy the rest of your evening.